The 2006 bridge over the Red River floodway, which protects Winnipeg, Manitoba, with twin 1,142-foot spans, is one of the largest GFRP reinforced bridges in the Canadian inventory. It's reported that lowered projected life cycle costs were a major factor in the decision to use composite reinforcements despite their higher initial cost. The light weight of the reinforcements made them easier to handle. In 2008, the American Association of State Highway and Transportation Officials approved design and construction specifications of concrete bridge decks using FRP reinforcing bars, allowing the use of this more sustainable technology in the U.S. Corrosion resistance was part of the reason why a prefabricated FRP composite deck was chosen for the 2004 restoration of the historic Broadway Bridge in Portland, Oregon. It was important to minimize the amount of time the bridge was out of service, and frequent openings for river traffic had to be accommodated as well. One of the prime objectives was to replace the worn-out open steel grid with a solid surface that would provide better traction when wet. However, the replacement deck would have to be similar in weight to the grid to avoid costly and time-consuming changes to the bascule operating mechanism. Nearly 12,000 square feet of FRP panels were placed by 2 light cranes in only 2 days. The highway bridge inventory in many states contains short spans in need of replacement, some dating back to the WPA. The experience of state DOTs to date suggests that short spans are a natural for prefabricated FRP composite deck systems. A bridge installed in 2005 for the Missouri DOT in Springfield is a case in point. In this instance, a proprietary grid design served as a stay-in-place concrete form. The rapid installation of the lightweight panels by light crane contributed to the estimated 70% reduction in construction time. The bridge redecking operations took only 5 days to complete instead of the 2 to 3 weeks normally required for similar steel reinforced decks built by the contractor. The inherent corrosion resistance of the new structure means it will enjoy a greatly extended service life compared to the span it replaced. Another example of a successful replacement of a short span bridge with a prefabricated FRP all-composite deck occurred in 2007 in Bradford, Vermont. The situation was a common one. The existing structure was never designed for modern loads. As the aging bridge deteriorated, it was no longer capable of carrying even its obsolete design capacity. Installation of the FRP composite deck sections, which were delivered to the site on a single trailer, was not affected by the November weather. The bottom sections of the FRP system were placed and mechanically fastened in 1 day. It's easy to understand why contractors and DOT engineers see FRP composite technology as a perfect fit for redecking aging truss bridges. FRP composite repair technology also provides a supremely cost-effective tool to extend the life of many deteriorated existing structures. A good example is the recent repair of Tampa's iconic Sunshine Skyway Bridge. Although less than 20 years old, cracks were discovered in many of the precast concrete girders during routine inspection. It was determined that the girders needed to be strengthened and that if left untreated, the cracks would allow corrosion of the steel reinforcements, dramatically compromising the 75-year design life of the bridge. Carbon epoxy FRP fabric sheets were successfully applied like wallpaper from a man lift on a large barge. In spite of the hot and humid environment, the job was completed a month ahead of schedule. Best of all, the use of this lightweight wrapping technology meant the extensive repairs could be completed without any disruption to bridge traffic.